All right, so today we begin Unit 8 with factoring, and we're going to start with GCF, greatest common factor of a polynomial. All right, now yesterday after the test, we looked at those pre-factoring worksheets where we talked about what are the factors, what two numbers, when you multiply them, you get this number, you add them, you get this number. All right, this is something kind of in reverse. Okay, and I tried to think about a way to make this handout more Jeffries friendly, and I hadn't really came up with a way. Okay, this part right here, I've never really understood it because it says factors, and like basically your factors are this. This is your product. This is your factors. These are your products. Okay, so it's like the distributive property in reverse. Okay. How many of y'all ever watched Rugrats before, like the original Rugrats when they're babies? Like one person? Okay. 2, 3. Awesome. I used to love their Rugrats. Now, I watched them when I was in 9th grade because we finally had cable. So they had an episode one time where it was, they called it a taker backer. Like they would give you something and then they ask for you to take it back. So this is, I call it like the taker backer principle. Okay. Now, steps for finding the finding the factor of GCF. Now, you probably have used GCF before with simplifying, right, fractions and stuff. And, you know, some calculators actually have a GCF function. I don't believe these do. There could be. I haven't really dug that deep into them. But there is a way that you can see, you know, how to simplify down and divide and factor and stuff. Now, the big thing is, if they have a variable, like if each term has a variable, we're always going to divide the variable with the smallest exponent. Okay. Then we're going to divide out and write GCF outside parentheses as a quotient. Basically, all of our answers are going to look like distributive property problems. Okay. All of our answers are going to look like that. And this is kind of the foundation for stuff we're going to be doing tomorrow. Slight foundation for what we're going to be doing on Monday. And believe it or not, this whole thought process of a GCF is actually one of the most used things in the real world. Okay. Where could somebody think that you use the GCF in the real world besides math class or as a math teacher? All right, well, let's think about common times. Symptoms of an illness: loss of smell, loss of taste, difficulty breathing. Those are common factors that all these people have when they have COVID. Another place that people have it, or that GCF is used, that a lot of people don't really think about, is actually online dating services. I know some of y'all are looking at me like, you're giving me that, are you sure you took your special vitamins today, Mr. Jeffries? Look, okay. But like on the eHarmony thing, where it says we matched you up on like a personality scale. Basically, they had a program that went through and you answer this inventory, and they try to come up with as many common factors as possible, and that's how they actually match you. Okay. One of the shows that my wife watches is this Married at First Sight, which is like another train wreck waiting to happen, where they actually get paired up by psychologists and relationship experts, and you just kind of sit back and watch to see if they make it or they explode. But they actually use something like this in common. Okay, so I've used that instance every year, and people give me the same look. Okay, say again, possibly. All right, now, so let's kind of look at this. Example one. What is the biggest number I can take out of 9 and 45? 9. Okay. Can I take an X out of both of them? No, because they both don't have an X. Okay, so 9 is our GCF. So this is the way you would write it. 9 goes on the outside. All right, now, what is 9x divided by 9? Yeah, 1x, or just x. Okay, and 45 divided by 9 is 5. That's it. Okay, yes, that's a simple one. Remember, kind of walk, jog, crawl, or walk, jog, run. So some people try to run, myself included. We would probably end up crawling later. Okay. All right. Let's look at number 2. What's the biggest number we can divide out of 8, 20, and 12? 4. Okay. I already heard of X because they each have an X, and that's the smallest one. Now, I'm going to kind of. The one thing I don't like about this is the way it's written, or kind of set up. I have a lot of students that they have to do this. And you don't have to do this if you don't want to. Like if this is the problem, they'll go through and then they'll do this to each problem, each term, so they know what's going on. Okay, bless you. So they put the GCF out here, and basically it's the leftovers after you divide out goes in the Tupperware or the parentheses. Okay, so 8 divided by 4 is 2. Remember, when we divide, we subtract the exponent. So if we had 3 of them, we take one out. Now it's x squared. Okay. Two x squared. Yeah. Mm-hmm. Yep. I always do the numbers first because for me it's easier. Okay, like this. Like 20 divided by 4 is 5. And then if you have 2 x's, you divide one out, you got 1. Okay. And then 12, and it's going to be a negative 12 or minus. 12 divided by 4 is going to be 3. And then if you have an x, you take it out, it's gone. So that's actually it. Okay. Well, because the original problem was 12x, and we're dividing out of 4x. You can't see that. Hold on. Now look back up. I think my face had the X over here covered. Yeah. So, yep. So like I said, if you can divide and subtract, you can do this. Okay. All right. So right here, what's the biggest number that we can take out of 18 and 12? 6. All right. So I'm going to go ahead and write it on the outside, and I'm going to do this so I can make it better. And then I've already heard of x cubed because that's the smallest power of x. All right. So the GCF goes on the outside. Now, 18 divided by 6 is 3. And if I have 6 x's and 3 of them mysteriously disappear, I just have 3 x's left. Okay. All right, 12 divided by 6 is 2. And what happened to Carol Baskin's husband? She disappeared. So just like that, our x's disappeared out here. Carol Baskins. Sorry, that's like the most stupidest show I've ever watched, but and it was just so funny. It's just one of those things you can kind of put your mind in neutral. You don't have to think about it. You just watch. Like, yeah. All right. Number 4, 15, 25, and 55. What's the biggest number we can take out of all those? 5. All right. What's the smallest power of x? X to the first. Yep. So I'm going to divide all this by 5x. All right. 15 divided by 5 is 3. If I have 3 x's, I take one away. I'm left with 2. Negative 25 divided by 5 is 5. If I have 2 x's, one of them goes away. I have 1. 55 divided by 5 is 11. And the x's will cancel. Now, one thing I didn't go over is when you're done with the stuff in the parentheses, the greatest common factor of what's left in the parentheses should be 1. You shouldn't be able to divide out anything else but 1. Okay. Now, I was the world's worst at simplifying fractions using the GCF when I was in school. I kind of still am. Okay. I use this technique that's my teacher called the whittling technique. Y'all ever seen something like an old man with a stick and he's sitting there with a pocket knife and he's just whittling on wood or trying to carve something? Takes him over. Google it. Anyways, he's sitting there trying to carve something out of that piece of wood and it takes a while. All right, so it's just like the fractions. Sometimes I'd have to go through and keep simplifying. It might take me longer, but eventually I'd get the answer. Okay. All right. What's the biggest number I can take out of 6 and 24? Can you divide 6 by 4? It's 6. Now, what usually happens on this one right here, the reason why some people said 4 is because in their head they were already dividing 24 by 6 and 4 was the answer. Okay, so our GCF is going to be 6 and it's going to be an x. So the 6's cancel. I'm left with just an x here minus 4. Okay, that's where a lot of people were getting the 4 a while ago. Now, what about number 6? 4. That's where you got your 4. Okay, and it's going to be an x. So 20 divided by 4 is 5x. 44 divided by 4 is 11, and the x is canceled. Okay. I can't move my face on the screen without making the noise. It just makes more sense to me. Whatever you're dividing out. It could be 1x, it could be 2x, it could be no x's. It could just be a number. Okay. Like if you were to follow along this right here, that's what's left after I divide out my GCF. This is what's left after I divide out my GCF. It's kind of like the leftovers after you divide it out. Now, what's the only thing we can divide out of 5x squared and x? Okay, that's the 1 is the number. Anything else? X. Just X. X is the only thing you can actually divide out of both of those. Okay? Now, we can't divide 5 by X, so we're just left with 5. Now, if we have 2 X's, we take 1 out, left with 1, and then just plus 1 back here. All right. Awesome. Okay. I'll move myself down here for a time being. All right. 20, 15, 20, 15, and 30. What's the biggest thing we can take out of all those? 5. Yep. And the smallest power of y would be y squared. All right, so that's what I'm dividing out this time. So 20 divided by 5 is 4. I have 4 y's, and I take 2 away. I'm left with 2. 15 divided by 5 is 3. I have 3 y's. I take 2 away. I'm left with 1. Yeah. 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 Remember, look, because this is basically like if I was to expand this out, this would be 5 times 3 times y times y times y over 5 times y times y. Okay. So the 5's cancel. We're left with 3. 2 of the y's cancel, so I'm left with 1. Yes. Yeah. Or you could use the exponent rule by subtracting. However you need to do. If you need to use the exponent rule, if you need to think about it this way. Ooh, here's a hard one. What's the GCF? Hang on, let me wipe this out. There we go. What's the GCF of 36, 63, and 27? Wow, everybody got that one that said it out loud. 9. I heard an X in there. All right, so 36 divided by 9 is 4. I have 3 X's. I take 1 away. I'm left with 2. This is going to be plus 7X minus 3. No, it's not. You just gotta, yeah, you just gotta know your rules. And I always approach stuff kind of numbers first, variable second. Numbers first, variable second. That works for me. It may work for you. It may not. Okay. All right. Oh, this one's fun. Let's do the number. What's the GCF, huh? You got the y squared right. Yeah. So if we start with the numbers, what's the GCF between 3 and 15? Well, that's 3. Okay. The smallest power of x is x cubed. Smallest power of y is y squared. And that looks like a hot mess right there. Cheese and crackers. All right. So why don't you do what I want you to do? Yeah, I just don't want to. Here. I just want to fix it normal. Dadgummit. I just want it to be normal. Yes, stuff that is normal does not happen in my class. Okay. All right. So, biggest number, GCF of numbers is 3. Smallest power x's is x to the third. Smallest power y's are y squared. That's a little bit written better, not a whole lot. Okay, so GCF goes up here. All right, the 3's will cancel. If I have 4 x's and I take 3 away, I'm left with 1. Crap, it's doing that thing where I can't see it again. Yeah, welcome to my world. All right, the y squares cancel. Yes, all right. So plus, all right, 15 divided by 3 is 5. X cubes cancel. Just y. Yeah, just y. Because if you have 3 y's and you take 1 away, or take 2 away, you're left with 1. Okay. Yep. All right. So this right here, if the leading coefficient, that's a big fancy word for it. If this number in the front is negative, you're always going to factor out a negative. Okay, if the number in the front is negative, you're always going to factor out a negative. All right. So we know it's going to be negative. What's the GCF between 2, 14, and 6? 2. All right, so we know we're going to divide out a negative 2. All right, what's the smallest power of x? Yeah, just x. Okay. Negative 2's canceled, so I have x to the third. Positive 14 divided by negative 2 is negative 7x and plus 3. Now, this part right here, again, is going to really be important tomorrow. All right, so we're starting to learn it today, like we're planting the seeds today. I had somebody in 4th block ask yesterday why we were doing that pre-factoring worksheet thing. I said, I'm planting the seed for next week. They said, why didn't we just wait till next week? I said, you ever planted something? They're like, yeah. I said, does it grow instant? And they're like, nope. Okay, it's got to take time. I know. All right. So we know we're going to divide a negative something out. What's the GCF between 5 and 35? Somebody is all over this today. All right. So the smallest power of x is x. Smallest power of y is y. Okay. So the 5's cancel. One of the x's cancel, and just the y. Okay. 35 divided by negative 5 is negative 7. And all those variables cancel. Pew. All right, this one has no numbers. So it has to be a variable that is our GCF. What is our GCF? X. So we're dividing by negative x. So we should get x squared minus x plus 1. And that's it. Good stuff. Roll time.